Next, we'll take a look at the intercepts of my function. There are two types of intercepts, an x and a y-intercept. The x-intercept is when the y or y value is equal to 0 and the function intercepts the y-axis. If we look here, the x-intercept will be anywhere along this line, and at this line y is equal to 0. That's why when we look for an x-intercept, we look for when y is equal to 0, because that is where the y value, where the equation will intercept the line. The y-intercept is the opposite, is when x, or the x value, is equal to 0 and the function intercepts the y-axis. This is because when the function will intercept this line anywhere, can intercept it anywhere along this line, and anywhere along this line x will equal 0. That's why we put x equals to 0 to find the y value. To find the y-intercept here, we set x equal to 0. So we plug in x equals 0, and what we come out with is negative 8 over 10, which can then be simplified to negative 4 over 5. And we see that there's only one y-intercept. We can tell this by looking at the graph, and here's a sketch right here, and that the function intercepts at this point. If I bring up a bigger picture here, the function intercepts the y-axis at this point. It'll never intercept it anywhere up here, or anywhere down here. So now we'll look at the x-intercept. Here we set y equal to 0, and then we solve. So first we want to get rid of this denominator, and we'll multiply both sides by the denominator. This will equal 0 on the left hand side of the equation, because anything times 0 equals 0. And here these will cancel each other out and will give us this. Now we want to find our root, and which we previously done before, we found out it was negative 3.325. What we see here is that because this is a root, it is also an x-intercept, because roots are when y equals 0. And we see right here on my little sketch that this is an intercept, or if I bring it up here, at around this value here, this is when the function will intercept the x-axis.